Hi, I am Prabjot Kaur. Welcome to another lecture. Today we are going to learn about a Wheatstone bridge. Wheatstone bridge is a circuit that looks like this or this. This is basically a special arrangement of resistors. And when we have a Wheatstone bridge like this, one of the things that we talk about is when the bridge is balanced. So let's analyze this circuit. But before we do that, you might question, what is this used for? So one of the use cases for a Wheatstone bridge is, let's say when you have four resistors connected like this and one of them is an unknown resistor, you can easily calculate the value of that resistor. So I would just use this Wheatstone bridge as a means to analyze circuits easily. Here we have a voltage applied, and we know that the current is going to flow from the positive side to the negative side. So when the current flows through here like this, at this node it's going to split I1 and I2, and then at this node it's going to split again, flowing through this, and then same thing at this node I2 is going to split through here and here. So that's what we know from our previous lectures. One thing that we need to know about the Wheatstone bridge is when the bridge is balanced. When we say the bridge is balanced, what we are saying is that the voltage at A and B is the same. And when the voltage between 2 points is the same, that means there is no voltage difference. That means there is no current that can flow between those 2 points. So therefore, all the current that is flowing from here to here, the same current flows here. Same thing. The current that flows through here, the same current flows through here. So I1 is equal to I3 and I2 equals I4. The other thing that we can see from this is, we know that the voltage here is just 1 point, and then voltage here VA, we are saying it is equal to VB by definition, because that's when the bridge is balanced. So that means the voltage drop across this R1 is the same as the voltage drop across R2. Similarly, the voltage drop across R3 is the same as the voltage drop across R4. So if we start to analyze that circuit, we'll come to the conclusion what Wheatstone bridge really does. So we said the voltage drop across R1, let's call it VR1, is equal to the voltage drop across R2, let's call it VR2. And by Ohm's law, V equals IR, we can rewrite this as I1 times R1 is equal to I2 times R2. Let's call this equation 1. Similarly, for the bottom part, we have voltage drop across R3, same as voltage drop across R4. So let's just call it VR3 is equal to VR4, and we can rewrite that as I3 times R3 is equal to I4 times R4. So we got two equations. And we said that the I3 is same as I1 because no current is flowing through here, so everything that's flowing here flows through here. So I1 is same as I3 and I2 is same as I4. So I can basically rewrite this as I1 times R3 is equal to I2 times R4. Let's just call it 2. Then if we divide these two equations, so I divide I1 R1, I2 R2. If we divide 1 by 2, I1 R3, I2 R4, we can cancel i's and we're left with R1 over R3 is equal to R2 by R4. So this is the result that we are after. So when we have a circuit arrangement that looks like this, which is a Wheatstone bridge, then we don't really have to analyze the circuit by doing what we just did. We can simply conclude that R1 over R3 is equal to R2 over R4. And this is important that you have to have the same voltages at this point. So the bridge has to be balanced for this to be true. That's all for this small lecture. I'll see you in the next one. Thank you. Bye.